Now, the last functional group we want to talk about is an acid anhydride. And as we know, anhydride means, related to anhydrous, means without water. So it's losing water. So let me draw a carboxylic acid. Okay. And then I'll draw another one in blue. So these are two carboxylic acids. And literally, when we combine acids together, this is just an example, we are literally going to lose water. And loss of water is dehydration, becomes anhydrous. And as a result of that, we have the formation of our anhydride. This is our anhydride. So that's an acid anhydride. The reason it's an acid anhydride is it's derived from an acid. So that you have your groups, your loss of water. You'll notice that in an anhydride you have a carbonyl bridging an oxygen. It's not two ketones and an ether. It's a unique group in which they're all attached to one another. Okay. So let's remind ourselves of some things that we have attached here. We have single bonds, we have triple bonds, we have double bonds. So you're going to see those in molecules. And realize a double bond potentially has alkene functionality, triple bonds, alkyne functionality. Over here we have an alcohol, and then we go wait. We can say that this carbon is attached to 1, 2, 3 carbons, so that's a tertiary alcohol. And if we look closely then at this bromo group, it's got 1, 2 attached, so this is a secondary alkyl halide. So there's a lot of information there just from simply looking at this molecule. In addition to that, we have to remind ourselves constantly, to find a pen that works, that this is an sp3 center, that this is an sp center, and that this is an sp2 center. And the bond angle here is 120 degrees, here it's 180 degrees, and here it's 109.5 degrees. And this geometry is trigonal planar. This is linear, and this is tetrahedral. Now I know I went a little fast there, but remember you can stop the video, rewind it, go a little closer. But more importantly, I want to emphasize that if the two lines come together down, remember the group's going to be down. If the two lines come together up the chain, then the group goes on top. That, remember, is to make sure that the lines are as far away from each other, because the line in a covalent molecule represents a bond, and a bond is full of electrons, and we know electrons repel each other. Highly repulsive. So let's take a look at something like this. So we've got this molecule. I'll move that up there so you can see it all. Now, if we look at this molecule, we should be able to identify functional groups such as this, which is an acid chloride, and this, which is an ester. Okay, so these are carbonyl functional groups. And then this one over here, which is a ketone. And over here we have this carboxylic acid. So those are examples of carbonyl functionalities within that molecule. So you can see even a complex molecule or a simple molecule like this can have lots of different functional groups. And then over here we have an ether. Yes, it's unsymmetrical, but we've just identified as an ether. Over here at the bottom we have a thiol. And with the sulfurs with 2 carbon chains on either side, it's a sulfide. So often in organic chemistry, this ability to identify these functional groups is going to be important in identifying bonds. Okay? Here we have an aromatic group. or arene. Finally, over here, well, we've got two more, sorry. Here we have an alcohol, and then you're going to say, well, let's check. It's got this carbon, it's got 1, 2 attached, so that's a secondary alcohol. And then over here we have chloro, which makes this an alkyl halide. And that's an alkyl halide, then this carbon 1, 2 attached, so that's a secondary alkyl halide. So we can identify these functional groups. But remember, with each functionality, we've got, is it a CO bond, a CH bond, a CN bond, a C halogen bond, such as CBr or CCl? Is it a double bond, such as C double bond C, C double bond O? Is it a triple bond, such as an alkyne, C triple bond C, or C triple bond N, such as is found in a nitrile? So all of these bonds are important in identifying stretches. So let's come back to that in the next slide.